in the aqueous state, react with BrO3 minus plus acid in acidic medium gives 3 bromine gas, 3 water. Water is a liquid. Now if this is my reaction, I have to find the rate. Let's do this for practice purpose. These are all my reactant and this is my product. So for reactant it will be minus, since it's a 5, minus 1 by 5, rate of change of concentration of Br minus by delta T, or this is nothing but there is no rate of coefficient, so it will be minus rate of change of BrO3 minus by delta T, or here there is a 6, so minus 1 by 6, change of concentration of H plus by delta T. This will always be equal to, again this is 1 by 3 because coefficient is 3, change in concentration of Br2 by delta T. Why there is no negative here? Because it is product. So this is equal to, again there is a 3 here, so 1 by 3, change in concentration of water by delta T. This will be my rate of reaction. Even that means the rate of reaction I can denote by this, or this. All will be same value. Correct? Let's take one example now. The question says that the decomposition of N2O5 in CCl4 at this temperature has been studied by monitoring the concentration of N2O5 in the solution. The initial concentration of N2O5 has been given, and after 184 minutes it is reduced to 2.08 moles per liter. This is my initial concentration, this is my final concentration, and the reaction is also given. We have to find the average rate of this reaction in terms of hours, minutes and seconds, and we have to also find the rate of production of NO2 during this period. So let's see this reaction we have. Let me write the reaction. 2N2O5 gives 4NO2 plus. So at T is equal to 0, the concentration of NO2 is 2.33 moles per liter. At T is equal to 184 minutes, my concentration is 2.08 mole per liter. Correct? So if you see the average rate, since the change in concentration of N2O5 is given, I can write as nothing but minus 1 by 2. Why minus? Because in the reactant signs. Why 1 by 2? Because 2 is in the coefficient. Change in concentration of N2O5 by delta T. Put the values here, minus 1 by 2, change in concentration of N2O5. Final concentration is 2.08 moles per liter. Initial concentration is 2.33 moles per liter. Divided by time is 184 minute. Correct? So this will come out to be in minute. So if you solve this, you get 6.79 into 10 to the power minus 4 moles per liter per minute. So minute is done. Correct? You want to find in hours or in seconds, divide this whole thing by 60, because in this minute, you say this minute into 60, that becomes seconds, right? So divide this whole thing by 60, this whole thing divided by 60, you get something as 1.132 into 10 to the power minus 5 moles per liter per second. Equation 1, this is 2. If you want to get in hours, then you take this equation 1 itself, multiply with the 60, because it is 184 minutes is nothing but 184 by 60 hours. So if you multiply this with 60, you get 6.79 into 60, it's almost 4.07 into 10 to the power minus 2 moles per liter per hour. So you see the same answer in 3 different units, 3 different values. So the units are pretty important here. This has done. The next question is, what is the rate of production of NO2? If you see, Using average rate, I have to find actually nothing but delta NO2 by delta T. So if you see average rate, I can also write as nothing but 1 by 4 delta NO2 by delta T. Correct, because 4 is here. That's my average rate. And this value I know. Average rate. Correct. This value I know. So this value is something I want to know. That will be nothing but 4 into average rate. So rate of production of NO2 is nothing but 4 into average rate of the reaction, the whole reaction. You multiply these values by 4 and you get the answer. If you want in seconds, let's take this value, the second one. 4 into 1.132 into 10 to the power minus 5, nothing but 4.52 into 10 to the power minus 5, and unit will be same, that is moles per liter per second. Pretty easy. So here we have to find the average rate in 3 different units. Once we are done with the average rate of this reaction, we have to find the rate of production of NO2. We know that average rate is nothing but 1 by 4 into rate of production of NO2. So rate of production of NO2 is nothing but 4 into average rate, which we just found out. Let's take one more numerical. It says from the reactant to product, this is my R is my reactant, P is my product. The concentration of reactant changed from 0.03 m to 0.02 m in 25 minutes. So I have my R to become P. T is equal to 0, the concentration of reactant was 0.03 m. At T is equal to 25 minutes, not in seconds, please note the units properly. My concentration of reactant became 0.02. Right? We have to find the average rate of reaction using units of both in minutes and seconds. Easy only. See, average rate of reaction, the word minus change of R with respect to T. Because there is a reactant, we have a negative sign. Coefficient is all 1, so there is no division. There is nothing but minus of reactant final concentration is 0.02 m. Initial concentration is 0.03 m, and change in time is in, you have to find minutes also, so let's put the minutes only, 25 minutes. So this comes out to be 0.01 by 25, and this is a minute. This is nothing but 0.004 moles per liter. M is nothing but moles per liter per minute. If you want to convert this into seconds, multiply with 60. Sorry, divide with 60 actually. This is minutes, this becomes 60, right? Divide this by 60. This is by 60 and you get moles per liter per second. You solve this, you get 6.66 into 10 to the power minus 6. Units will keep the same, moles per liter per second. And that's the answer. Correct. The rate of change of concentration of product is given, sorry, reactant is given. We have to find the rate of average rate of reaction. We know average rate of reaction is nothing but rate of change of reactant by T with a negative sign. Put the values, get the answer. It is in per minute, moles per liter per minute. The question asked to find the values both in moles per liter per minute and moles per liter per second. So we divided the whole thing with 60 to get in moles per liter per second. Why? Divide by 60 because you see minute is in denominator. If you want to make this 25 minutes as 60, if you want to make this 25 minutes as in seconds, you have to make it 25 into 60 seconds, because 25 minutes nothing but 25 into 60 seconds, right? So either you write 25 minutes here or you write 25 into 60 seconds. So if you are saying 25 into 60 seconds, that means you are dividing the whole thing by 60. Let's take one more example. The reaction 2A becomes product. The concentration of A decreased from 0.5 moles per liter to 0.4 mole liter in 10 minutes. We have to find the average rate of this reaction during the interval. Pretty easy question. 2A to product. T is equal to 0, the concentration was 0.5 moles per liter. T is equal to 10 minutes. 10 minutes. This is 0.4 mole per liter. So my average rate of reaction, I know nothing but change in concentration of reactant with time, and there's a 2 here, so 1 by 2, and there's a change in reactant, so there's a negative sign. So this is what I have to find, minus 1 by 2 into the change in concentration is from minus 0.4 moles per liter to final concentration, initial concentration, by time 10 minutes, correct? So this becomes 0.005 moles per liter per minute. Unit is important.